Hi everybody. In this video, I'm going to teach you about field maps. We'll take a look at what they are, why we use them, and then how we make them. We're going to spend the next several days in class creating field maps and analyzing field maps. So this video will give you all of the background knowledge you'll need to be successful over the next several days. So let's start off with what a field is. A field is just any area on Earth or in space that has some measurable value at every point. So in other words, if we were to look at a galaxy such as this one, in the galaxy, at every single point, there's something that we could measure. We could measure the temperature. We could measure the brightness of stars. We could measure the number of stars. We could measure the size of stars. Each of those things is a field. In this photograph of this glacier, what we could do is we could measure how thick the ice is in this spot, and how thick it is in this spot, and how thick it is in this spot. At every point on this glacier, we could measure the thickness. We could also measure the temperature. In a classroom, we could measure the height of objects at every point in the room. So that would be considered a field. We could measure the elevation of this landscape. So at every single point in this landscape, we could measure the elevation. So that's all a field is. It's just some area where we can measure something at every spot in that area. Other fields that you probably have seen either on TV or in the newspaper would be a map like this that shows the temperatures. So we can look at North America and we can measure the temperature at every single point. We can look at air pressure. These lines are showing us the air pressure at different points in North America. We could look at elevations. So in this map of New York, the different colors represent different elevations in our state. Every place in New York has an elevation, so that's a field. We could measure wind speeds. We could measure how much snowfall is expected at different points when we have a winter storm. We could measure the relative humidity. So anywhere in the United States, any single point in our country, we could measure the relative humidity. So those are all fields. Now on the maps we just looked at, you noticed lines on all of them. Those lines are called isolines. And what they do is they connect all of the points that have the same value. So if we look at this line, let's say, every single point on this line has the same value. Now this map is showing us earthquake hazards. So all of the places on this line have the same degree of chances of having a devastating earthquake. Every place on this line has the same amount of earthquake hazard that could happen. On a map like this is a map that's showing us how much we might need to use our heat or our air conditioning. So any place on this line over here, it's estimated that they would need to use the same amount of heat. Or any place on this line, separating the dark purple from the light purple, they would be expected to use the same amount of air conditioning. So all the points on that line have the same value. This map shows us fall foliage. So if we look at the bottom of this yellow, this line over here, all of these places are going to have the same amount of foliage. We could look at the pH, or the amount of acidity of the precipitation. So if I choose this line right over here that separates the dark green from the lighter green, all of the points on this line have the same amount of acid in their precipitation. This one I like. This is for people with arthritis. This tells you how much achiness you might have on this given day. And so if you live anywhere on the edge of this yellow section, people with arthritis would be expected to have the same amount of achiness. So those are all isolines. There are three main types of isolines that we're going to be using this year. The first type are called isotherms. And these are lines that connect points of equal temperature. Earlier we had looked at this map showing us different temperatures across the United States. These are isolines, but because they're showing us temperatures, we have a special name. We call them isotherms. When we're looking at air pressure, the isolines are called isobars. And that's because air pressure is also known as barometric pressure. So bar, barometric. And the unit that we often use are millibars. So isobars are just isolines that show points of equal air pressure. When we're looking at elevation, we use what are called contour lines. So again, they're just a type of isoline that show points that all have the same elevation. So now I want to go over some of the rules for how we create field maps and for how we draw isolines. The first rule is that when you draw an isoline, you have to connect all of the points that have an equal value. So let's say you were given this data and you were asked to draw the isoline for the value of 10. You would just need to make sure that your isoline went through all of the 10s. Okay? Every single 10 would have to be connected by that line. The second rule is that your isolines have to be gentle curving lines. We don't want straight lines. We don't want sharp corners like you could see over here. This is no good. And the reason for that is because if you're looking at temperature or something, the temperatures in an area are not going to change so drastically that you'd have a sharp angle or a sharp corner between one place and the place next to it. Okay? So we want smooth curving lines. The third rule is that isolines almost always form loops. However, sometimes the whole loop doesn't fit on our paper. So this rectangle here, this represents a map. You'll notice that these isolines here, they are forming closed loops, but the map ends over here. So we're not going to see anything that goes off the map. So the rule is they have to be loops or they have to get to the edge of the map. Okay, so we want to make sure when we're drawing these, our isolines either have to make a loop or they have to go all the way to the edge of the map. Okay, rule number 4. Isolines never cross each other and they never ever touch each other. I want you to see if you could figure out why that is. Take a look at the picture. Why do you think it's impossible for two isolines to cross each other or touch each other? Well, hopefully you realize that the orange line represents places that are 30 degrees, and this white line represents places that are 40 degrees. If two lines touch, it means that this one point is 30 degrees and 40 degrees. And we know it's impossible for one point to have two different temperatures. So that's why your lines can never cross and can never touch each other. Fifth rule, and this is a rule that's really helpful as we start to draw these. You're going to find that isolines are usually somewhat parallel. So once you draw one, you'll often notice that the ones around it are fairly parallel to it. It may not be perfectly parallel, but they're fairly parallel. And the last rule is that the contour interval, okay, so the interval is just the difference in value from one isoline to the next one. The interval between them must be constant. So if these two lines have an interval of 10, it means all the lines on the map have to have an interval of 10. It's just like when you're making a graph and you start numbering your x-axis, you have to make sure there's a constant interval between each of the lines that you number. Okay, same thing with field maps and with isolines. You need to use a constant interval. So what I would like you to do is I'd like you to go into your packet and I want you to work through what I assigned for homework tonight. Keep these 6 rules in mind, and tomorrow we'll go over what you're about to attempt. I think you'll be okay. Do it in pencil in case you have any trouble. You can always fix it in class tomorrow. Okay? Feel free to rewind, rewatch it if you need to. And I look forward to exploring field maps in the next couple of days. So long.